All right, welcome to lesson 4 of module 6. Today we're going to be basically just interpreting graphs and their quantities and figuring out which description matches which part of the graph, what the parts of the graph actually represent in terms of a situation. You'll know you're successful when you can sketch the graph that exhibits the qualitative features of a function based on a verbal description. Let's go ahead and get started. All right, for this first example, we're going to read through each of these situations off to the left and match them with a graph to the right. Okay? So A says a bathtub is filled, that's a keyword, it's being filled up at a constant rate of 1.75 gallons per minute. So one thing I want to note about this is that when we're filling something up, it's gaining more water each minute, so it's going to have an increasing slope. So it's either going to be this one right here or this one, okay? But we won't know until we figure out the other descriptions here and compare it to see if the slope is higher or less than another slope. So B says a bathtub is drained at a constant rate of 2.5 gallons per minute. Well, if it's being drained, it is losing water. So it's going to be decreasing. Well, the only slope here that is decreasing is this one right here. So I'm going to go ahead and say that this one matches B because it is decreasing. It's losing water as time goes on. Okay? The next one, it says a bathtub contains 2.5 gallons of water. So this is neither increasing nor decreasing. It is just a steady line. It's just stagnant. It's not moving at all, up or down. And so the only one that matches this is this last one down here. Okay, you can see that this line is just straight the entire time. It's stagnant. And then our last description says a bathtub is filled at a constant rate of 2.5 gallons per minute. So this, again, is increasing, all right? And it's increasing at a rate that is a little bit higher than that first one that was increasing. So it's going to be steeper than the first one. So the steepest graph on here between these two right here is this one. So this is graph D, which means that the first one, graph A, would be right here, okay? And this is pretty much what we're going to be doing today, is just matching descriptions to graphs and interpreting what these things look like when we're to graph them. Okay, make sure you have this down, and we're going to do a little bit of practice on the next one with the same kind of questioning. Alrighty, what I want you to do here is pretty much the exact same thing we just did. Read through these descriptions and then match them to a graph. So A says, the tire pressure on Regina's car remains at 30 psi. B says Carlita inflates her tire at a constant rate for 4 minutes. And C says air is leaking from Courtney's tire at a constant rate. So take about 1 minute and match these graphs to each of those, A, B, and C, and then we'll go over them. All right, for A, the key word here is remains. That means it is going to be a steady line, like this one right here. So this is scenario A, and the explanation remains means that it's neither increasing nor decreasing. Okay? All right, moving on to the next one. It says Carlita inflates her tire at a constant rate for 4 minutes. So if it's being inflated, then we are getting more pressure in this tire as time goes on. So we are increasing for our rate, so it's going to be a positive slope. So this is scenario B. So the word inflates means we are increasing in rate. Right? We're increasing that PSI per minute, and PSI is just how you measure the air within something, okay? And then C, it says air is leaking at a constant rate. Leaking, that means it's going to be decreasing, right? Your tire's getting flat. It's losing air. So this is scenario C, and leaking, this indicates a negative slope. All right, hopefully you were able to get those 3 down, and if you didn't, you can go ahead and write them down now, and we're going to move on to the next example. All right, for example 2, it says that we need to read through these scenarios and then sketch a graph to model the situation. So it says a messenger service charges a flat rate of $4.95 to deliver a package regardless of the distance. So they're just going to be charging this flat rate. That means it's not increasing or decreasing, it stays steady. So they're charging $4.95. It's going to be probably right about here. And so I'm just going to draw a straight line, as straight as I can make it. And that's going to represent my graph here. It's a flat rate. There's not an increase or a decrease. Moving on to part B. All right, for this situation here, it says at sea level, the air that surrounds us presses down on our bodies at 14.7 pounds per square inch. For every 10 meters that you dive underwater, the pressure increases by 14.7 psi. So the key word here is that it increases. Okay, so for every 10 meters, it's going to increase by 14.7 psi. So at 10 meters, which is going to be right about here, we're going to be at about 14.7 psi. At 20 meters, when we double that, we're going to be about, well, 14 doubled. That's like 28, so it's going to be right about like 30. Okay? And this is not accurate at all. This is not like a great graph by any means, but I'm just showing that it's an increasing slope. Okay? Make sure you have that down and we'll move on to the next one, C. All right, part C, it says the range, driving distance per charge, of an electric car varies based on the average speed that the car is driven. The initial range of the electric car after full charge is 400 miles. So this is the initial range or initial value. This is where we're going to be starting. Okay. However, the range is reduced by 20 miles for every 10 miles per hour increase. So we're starting off before you go fast at all. This car can go 400 miles. Now, if you go 10 miles per hour faster, so this is where 10 miles per hour would be, you're going to be reduced by 20 miles. So we subtract 20 miles, it would be 380, right? Okay, we go another 10 miles, and we're going to be going 20 less than that. So it would be, well, 380 minus 20, 360. Okay, and it's just going to keep decreasing at this rate, right? The faster you go, the more electricity you're using, and the less charge your car is going to have. It's decreasing. All right, moving on to our next part. All right, for example number 3, this is very similar to your exit ticket today, so maybe pay close attention here. It says the graph below represents the total number of smartphones that are shipped to a retail store over the course of 50 days. Match each part of the graph, A, B, and C, okay, to its verbal description. Explain the reasoning behind your choice. So that says half of the factory workers went on strike, and not enough smartphones were produced for normal shipments. Okay, well, if half of them went on strike, there's still going to be some people making smartphones, right? It's just not going to be as steep as an increase, so it's not going to be as many smartphones being made. Okay. The next one says the production schedule was normal, and smartphones were shipped to the retail store at a constant rate. Okay, so it's normal. And then the last one says a defective electronic chip was found, and the factory had to shut down, so no smartphones were shipped. So I'm going to start there because that seems like the easiest part. Which section in the graph would this match? If no smartphones are shipped, then there's not going to be any increase on this axis over here. It's just going to be steady. So this would be part B right here. No increase. You see that there's no slope there at all. It's just completely straight. Okay, the next two parts are a little bit more difficult, but now I can kind of decide, is it going to be A or C? So the first one says half the workers went on strike. So that means that we're going to slow down. It's going to be less steep. than normal. Okay, and this right here is just normal. So which one of these slopes are less steep, A or C? Well, in my opinion, part C is less steep, right? It's not as steep of a line. It's still increasing because we still have some people working, but half of the factory workers went on strike. So it's not going to be as steep as normal. Okay? And then that leaves part A. This is a normal rate of increase. So that would be this section right here. Okay, let me know if you have any questions before we move on. All right, based on what we just did in the last example, I want you to try this here. It says the graph below displays the first hour of Sam's bike ride. Match the parts to the descriptions below. First one, Sam rides his bike to his friend's house at a constant rate. Second one, Sam and his friend bike together to an ice cream shop that is in between their houses. And the third one, Sam plays at his friend's house. Really look at the different axes here. So this is time as time goes on, what's happening. And this is the distance from home. So how far he rides away from home. Okay? Go ahead and try this out and then we'll go over it. All right, the first thing I thought would be easiest to identify here is this stagnant part right here. When are they not riding their bike? Well, it's when they're playing, right? They're just staying at the same place. They're not increasing or decreasing the distance away from the house. So this is going to be part B. They are not riding the bike at all. And so the distance is not changing at all, right? We're not going up or down on this axis. Okay? From there, there's a few things happening. So the first thing, it says Sam rides his bike to his friend's house at a constant rate. The next one, they bike to an ice cream shop that's between their houses. So what has to happen first? Well, he has to go to his friend's house first. So that's going to be this section right here. Okay, it's when he goes to his friend's house because they can't go to the ice cream shop unless they're together, right? So this is part A. This happens first. And as time goes on, he gets further away from his house. He gets to his friend's house. They play, and then they decide, hey, let's go to an ice cream shop that's in between our houses. So he kind of gets closer to his house again, right? So that would be part C of this graph. Because the ice cream shop is in between their houses, so he kind of goes back towards his house. With his friend. Okay? Let me know if you have any questions here before we move on. All right, exercise 4. It says a home was purchased for $275,000. Due to recession, the value fell at a constant rate over the next 5 years. Sketch a graph that models the situation. Okay? So one thing you should know is that before the recession happened, this was the initial value of the house. And then the only thing it tells you is that it decreased in value. So I want you to make a graph that shows this. Okay? Go ahead and do this right now. All right, I'm going to show you my graph. So I would say we're starting at about right here on our y-axis. I'm just going to say that's around $275,000. And then over time, we're decreasing. So the value of the home is being lost. Okay? Over the next 5 years. So I'm just going to put random dots here. Now, why would this not make sense? Any ideas why my graph that I just put here would not make sense? Well, basically this says that in 5 years, the house is going to be worth $0. Homes are never going to be worth $0. So I made way too steep of a decrease. Okay, it decreased way too much. So I'm going to not use those blue dots, and I'm going to be using a red dot instead. I'm saying, well, maybe after 5 years, we are, not at $0, maybe it's at like $100,000 or something, okay? So maybe we're right here. So maybe my slope is a little bit less steep, but it's still decreasing because we want this to actually make sense still, okay? So it says, based on your graph, how is the home value changing with respect to time? Basically, our graphs should just show that it decreases. Decreases over time. Okay, because it is a recession. And that's all you had to really do here. No actual math, just showing that the line decreases. Moving on. All right, our lesson summary today says that a function whose graph has a positive slope is increasing. A negative slope is decreasing. And zero slope, when it's just a straight line, it's just a constant function. It's not increasing or decreasing. It's just stagnant. It's constant. Okay, let's look at our exit ticket before you guys get into it. All right, here's your exit ticket for today. You're going to have to match the different parts of this graph, part A, B, and C, with these descriptions below. Okay, really look for keywords. Go back. We did a couple of these in our notes if you need help, and then do your lesson reflection in Google Classroom. Good luck.